Jai Hind everyone. Myself Pradeep Kumar Tripathi, Assistant Professor in Department of Information Technology, Akgec Garg Engineering College, Ghaziabad. Today we have discussed about the lecture series on the subject Database Management System, that is target oriented of third year CS and IT students. Now we start the today topic. We have discussed about the ER diagram in the DBMS, how we can develop a ER diagram for the particular scenario. Suppose we want to design a database for any particular organization or any particular enterprises. We can identify the entities and attributes, and we can map all these in a particular diagram. So we can easily map in the table by the help of ER diagram. So particular ER diagram can be give the brief idea about the how the table can be structured in the particular DBMS. So let's discuss about the ER diagram in a particular DBMS. What is ER? That is, E stands for entity and E stands for entity and R stands for relationship. And it is a high level data model that we can define the data elements and relationship between the specified system. We can develop particular ER diagram. So it is a basically conceptual design for the database, and we can develop for the understanding of the particular data or understanding of the particular database. In the particular ER modeling, database structure is portrayed as a diagram called ER relationship diagram. Suppose we have taken the example of school, then in the particular school we have taken the example of a school database. We can easily find out we can design a school database. In this database we can identify the particular name, ID, age, addresses, and these type of entities we can connect with the attributes, and we finally draw the particular database structure. How we can draw the particular database structure in a particular DBMS? We can draw the particular database we can easily draw a diagram, that is student. We can see over here, this is student, and this particular student we can easily identify. We can draw by using this. This is for the entity and this is for the attribute. The rectangle shows the particular entity and the oval shape shows the attribute. We can easily map this particular diagram to draw the student entity relationship diagram. In the student entity relationship diagram, we can draw the entity student, and we have 4 attributes we can connect it from that particular entity. In this entity, student entity, we can connect name, address, age and ID. These are the 4 attributes of the particular student entity. So this is called a simple ER diagram for the student entity in a particular school database. How we can identify? If we summarize the component of ER diagram, then we can discuss this type of scenario. ER model, we can divide the entity, attribute and relations. First of all, we have discussed about the entity. What is entity? An entity that can be exist in a real world, that is called entity. A real world things that can be exist is called entity. In the entities category of 2 types. One is weak entity, another is strong entity. Normal entity we can draw, we can call the strong entity. If we cannot define the particular entity scenario, then it is called weak entity. Either it is called, if one entity can be dependent on second entity, this is called weak entity, and we can denote it by this. This is the denotation of weak entity. This is denotation of weak entity, and in the previous example we can draw the student entity, that is called a strong entity. So if we can draw the ER diagram for a particular scenario of a database, then we can draw entity. An entity can be two types, one is strong entity and another is weak entity. In the strong entity, we can show over here student is a strong entity, and here we can use this type of symbol that is denoted at the weak entity. Now next part, that is attribute. What is attribute? Attribute can be defined the characteristic of that particular entity. If we have a student, then student has an entity and the name, address, age and ID. These are called attributes. These are called attributes, and attributes are four types. One is key attribute, another is composite attribute, multi-value attribute and derived attribute. What is key attribute? In the particular entity, one attribute is make as a prime attribute or key attribute, because in the particular key attribute, we can identify that particular attribute and separate the data and separate the data on the basis of key attribute. Suppose we have a student entity. Here we can denote ID as a key attribute, because ID is a unique attribute that we can distinguish the data of student in the particular table or in the particular database. So in these four attributes, if we define at this, one attribute is this, second is this, third attribute is this, and fourth attribute is this. These are the four attributes, but in the four attributes, we can define fourth one is a prime attribute or key attribute, because in this particular attribute, we can easily map the data by using this particular attribute. The key attribute is the main attribute that we can identify the data in the particular database. Another is composite attribute. If we do not find the key attribute in the particular table, suppose we have a table of student, we have a name of ID, name, address and mobile number. Suppose we have a four attribute. These are the key attribute. If we cannot find the key attribute in a particular table, then in this particular scenario, we can combine two attributes as a common attribute and make it as key attribute. This is called composite attribute. If we cannot define in a particular table a key attribute or prime attribute, then we can define that particular attribute to a key attribute. We can merge two attributes in a one and consider as a key attribute. This is called composite attribute. Now next is multi-value attribute. What is multi-valued attribute? If we have a attribute of our entity and we have more than one value can be exist in that particular attribute. Suppose we have a name attribute, we consider only one entries in a particular row. In address, we can consider one attribute. In mobile number, we can consider as one. But it can be possible of address, we can possible the two address of that particular one student, and the two mobile numbers are possible in that particular student, but we cannot possible the two names of the student in particular table. So in this particular attribute is called multi-value attribute. Suppose we have a more than one value of that attribute can be exist. Suppose we have a student attribute. If two addresses can be possible, we can circle of these. This can be represented as the multi-value attribute, MVD, multi-value attribute, MVA. This address is called multi-value attribute. Now next is derived attribute. What is derived attribute? If one attribute can be derived from the another attribute, suppose we have a student relationship. In a student relationship, we have a DOB, date of birth, and age. Age is calculated by the help of DOB. So age is called derived attribute, and it can be represented by the dotted lines. Suppose in a particular ER diagram, we can denote it as a age. This can be comes from the DOB. This is called derived attribute. So these are the 4 types of main categories of particular attribute. One is key attribute, composite attribute, multi-value attribute, and derived attribute. These are the 4 types of attributes that can be exist in a particular scenario. Now next, we have find out the relation. What type of relation that can be exist in a particular ER diagram? There are the 4 types of relation that can be exist in a ER diagram. One is one to one, one to many, many to one, and many to many. Now next, discuss about the one to one. What is one to one? If entity can be related from one entity to directly connected with another entity, this is called one to one relation. Suppose we have a relationship of 2 entities. Suppose we have a particular 2 type of entities can be connected in a this particular manner. This is called one to one and one to many and many to many relationship. How we can describe, we can see over here. Just a minute. Suppose we have one entity and here is one entity, and this can be connected like this particular manner. This is called one to one. Suppose one to many, suppose here one entity and that can be connected from one to, this is called one to many. Just opposite, many to one. And if more than one relation can be exist in the left hand side and right hand side, this is called many to many relations. So this is the component of ER diagram that we have discussed about entities, attributes, relations. How we can define that particular entity? If we have a question of what is entity, an entity may be any an object, class, person, or a place. In particular, entity can be represented as the rectangular box. There are the 2 type of entity we have already discussed about, strong entity and weak entity. If we talk about the weak entity does not contain any key attributes of its own. Weak entity is represented by the double rectangle. We have already discussed the weak entity. Now we have already discussed the attribute, what is attribute, and these are the key attribute, composite, multi-value, and derived attribute. We have already discussed this particular attribute. And multi-value attribute, we have already discussed what is the multi-value attribute. If one attribute can have the more than one value, this is called multi-value attribute. If let's take an example of ER diagram. Suppose example, person age can be changed over the time and can be derived from another attribute like date of birth. Here we can show the derived attribute of a particular scenario. Suppose we have a student has the 4 type of attribute. One is name, birth date, roll number, and age. Age can be derived from the date of birth. So it is shown as the dotted lines. This is called derived attribute. This is the live example of derived attribute. If any attribute can be derived from another attribute, it is called derived attribute. And relation, we can discuss about the relation. Suppose we have one-to-one relationship. What is relationship? A relationship is used to describe the relation between entities, and in this particular entities we can show the diamond shape for the represent the relationship. Suppose we have example of teachers and student. We have described the relation teaches. The teacher can teaches the student, and the teaches is the relationship, and we can show the diamond shape. And for the one-to-one relationship, we have suppose a female can marry one male and a male can marry to one female. That can be shown in the diagram. A female, one can marry to the male, either it is vice versa, one male can be married to the female. That is the example of one-to-one relationship. When exists one-to-one relationship? When only one instance of an entity is associated with the relationship, then it is known as the one-to-one relationship. And one-to-many relationship, when only one instance of the entity on the left hand side and the more than one instance of another entity on the right hand side associate with the relationship, it is known as one-to-many relationship. Suppose we have an example of scientists. Scientists can invent the many inventions, but in the invention can be done by only the specific scientist. This can be relation shown in the one-to-many relationship. Scientist, here one is scientist and invents the more than one inventions. So we can relate from this one to M. The M stands for many. So this particular relation is called one-to-many relationship. What is many-to-one? A student can enroll only one course, but course can have many students. This is called many-to-one relationship. And many-to-many relationship we can assign from this particular scenario. Many-to-many relationship we can when more than one instance of the entity on the left and the more than one instance of the entity on the right associate with the relationship, it is known as the many-to-many relationship. Suppose we have taken the example of employee can assign many projects and project can have many employees. If we denote by this example M to M, this is called our many-to-many relationship. If we can summarize the denotation of notations of either denotation of the ER diagram. Suppose we have this type of particular scenario, database can be used this particular notations for the purpose of ER diagram. Suppose one-to-one relationship, you can apply this type of lines. If we can use the one-to-one, one-to-many relationship, we can use this particular arrow, and if we have to many, then we can use this one or more, then we can use one and only one, 0 to 1 and 0 to many. These are the options we can use that particular database ER diagram scenario. Here is the brief of this particular notations we can use in this examples. In the particular ER diagram, there are some cardinalities in a DBMS. What is cardinalities? Cardinalities means that is the constraint we can use in particular mapping of the entity. So it is also called the mapping constraint, either it is called cardinalities in DBMS. In the particular DBMS, software which is used to the various operation in a database, like the creation of the database, deletion of the database and updation of the current database. For the simplify the queries and data, we can use the row and columns of a particular table. We can use SQL for the easily writing query and data in the particular database scenario. The SQL is basically one language that can be interacted with the database. We can use SQL for the writing the query purpose. In the cardinalities means how the entities are arranged to each other and what is the relation structure between the entities in a relationship set. In a database management system, cardinality represents a number that can be denoted how many times an entity is participating with the another entity in a relationship set. Suppose we have the example in the table, number of rows and number of tuples represent in the cardinalities. In the cardinality, we can calculate the cardinality ratio. In the cardinality ratio, we can easily identify the cardinality ratio for the purpose of relationship. In the cardinality ratio, which represents the mapping of one entity set to another entity set, we can easily take the example of binary relationship set. Two entities set are mapped to each other. There are the four segments we have already discussed: one to one, many to one, many to many, and one to many. We have already discussed about this. Suppose we have take some examples of ER diagram. Suppose we need to create some ER diagram for the car, or some ER diagram for the student, some ER diagram for the faculty member. If suppose we have draw the ER diagram for faculty member, how can we draw? We can take a example of faculty, one entity, and how the attribute can be connected in the particular entity. We can draw like this. Suppose faculty, we can take the ID of faculty member, faculty name, and here is the department. Here can be subjects. There are many more attributes we can connect it over there. This is a simple example of faculty member. We can easily draw the ER diagram of faculty. If we can connect that particular student diagram, suppose we here is the student, and we have a particular roll number student. Here is the name, here is the section, and this can be connected by the shape of diamond to the faculty. Faculty can teach us the student. This is a particular one ER diagram for the two entities. One is faculty and student. We can easily draw that particular diagram. In this particular diagram, we can easily draw a particular diagram because we can identify the two entities. One is faculty and another is student. We can draw one by one. Suppose we can firstly we have draw the faculty entity, and we can connect these attributes from the faculty. We can easily draw from the student entity, and we can draw the attribute of student, and after this we can connect it from the diamond shape to the student to faculty, and this is the one complete ER diagram for the student and faculty. Like this, we can draw all the diagrams that is related to the particular scenario. If suppose we have given the sub examples of the employee project management system ER diagram, like library management system and ER diagrams, like car system diagram, we can easily, first of all, we have a one goal. We can collect the information from the particular scenario, and this particular scenario we can take the and identify the particular entities. First of all, if suppose we have some examples, suppose we have an example of, suppose we can draw the car, and we can draw the car, and we can draw the vehicles, and we can draw the library management, and we can lots of examples of ER diagram we can draw in that particular scenario. Suppose we have one scenario. Suppose we have a given for our library management system. How we can identify that particular scenario? First of all, if any question can be given in ER diagram, first of all, our goal is identify the entity. First of all, we can identify the entity, and we can draw that particular entity. After that particular entity, we can identify the attribute of that entity. After the identifying the attribute of that particular entity, we can easily identify the key attribute and multi-value attribute. We can easily identify the key attribute and multi-value attribute. Agar if possible, then we can derived attribute also, we can identify the derived attribute also. After these filling of these identify of these particular three things, then we can make the identify another entity and follow these process. After that, we can identify the relationship. These 5 steps, we can easily draw an ER diagram of for particular any scenario that can be given into the example. Suppose we have example of car, library management system, employee management system. We can draw. Suppose we have taken the example of employee management system. How we can identify the entities? One is employee, another is department, another is HR, another is company name, and these type of particular entities. If specify the mention the entities names, then we can take that particular entity. If we cannot identify, if we cannot mention in the specified entities, then we can take by own self. If mention, then particular it is strict to take that particular entity. If not strict, then we can take the example of any. Suppose employee management system, we can use one entity is employee, another entity is project, third entity is company, and these three types of one entity is employee, another entity is project, another entity is company. We can draw this particular entity's attribute, we can draw this particular attribute and this attribute, and these three entities can be connected by the relationship, that is the one to one, one to many, or many to many, or many to one. This is the practical example of to draw the ER diagram. Identify these 5 steps, identify the entity, attributes, key attributes, multi-value attributes, and derived attribute, identify another set of entities, and we can make this particular relationship in this particular scenario. This is called how to draw the ER diagram in a particular given particular scenario. Right. And further we have moved on the 3 main topics of the ER diagram that can be included in an ER diagram, and it is called extended ER diagram. Suppose extended ER diagram, what extended ER diagram? That can be a simple ER diagram plus these 3 properties. One is generalization, second is specialization, and third one is aggregation. If we conclude these 3 major specialties to the ER diagram, this is called extended ER diagram. What is generalization? If we can draw the ER diagram easily, we find out the entities and draw that particular entities, and after the entities we can use these 3 major characteristics of the ER diagram, and that can be called as a extended ER diagram. So let's talk about the generalization. What is generalization? Generalization is basically like a bottom-up approach in which 2 or more entities of the lower level to combine and form a higher level of entities if they have some attribute in common. In the generalization, and entities of higher level can also combine with the entities of lower level to form a further higher level entities. Like example of subclass and superclass concept. It is a bottom-up approach. Suppose we have an example of this particular faculty and student entities can be generalized and create a higher level entities person. Suppose we have a faculty entity and student entity. These entities can be is a relationship with a person. This is called generalization of that particular entity. So this is the concept of generalization. How we can form a two entities of lower level to combine higher level entities. Okay, next, thank you everyone. We will discuss these properties, generalization, specialization, aggregation in the next lecture series. Thank you everyone. Jai Hind.